Okay, so yesterday, like I was in school and I was thinking about math as you do during other subjects, and it occurred to me that, you know, maybe this can be factorized. Now I'll show you how. So we have the relation here, right? Y is equal to 1 over x up here. Yeah, hopefully that's visible. So we can convert this y squared. Okay, I'll write it out here. So just AR of our beloved Harambe. 4 times x naught squared plus y naught squared, right? This we derived in the last video. I'll link it down in the description. So okay, this is y naught, because why not? I have to stop with that joke. Yeah, is indeed. Now we'll write this x squared plus y naught squared, x naught squared plus y naught squared as x naught squared plus 1 over x naught squared. Because y naught squared, now we can write this as y naught squared. We can write this as 1 over x not whole squared. So that's how we get that. So that's pretty good. So far so good. Now okay, close the bracket. Now let's look into factorizing this part, right? Because it looks ugly and I don't like ugly things. So okay, let's adjust the focus first. Yeah, that's good. X, you know what, we'll just call it x for now. So right now this is just a note. Call this a note. So we have x squared plus x naught squared. So we write this as x squared plus 1 over x squared. Now see, this is like generally not factorizable, but this is more like a forced factorization because I want it to be factorized. Meh. So we can write that as x to the 4th plus 1 over x squared. Now if you're wondering how that's true, you need to brush up on your algebra, I guess. Yeah, that's all I can say. So we have that much with us, that information with us. Now we want to write this as, so we want to factorize out, let's see. Well, we'll see. So, okay, let's try to factorize this, right? So, of course, it's the sum of two squares. Let's write it out as this is equivalent to x squared plus 1 squared, and this is x squared. Now we want to write this. Okay, so the purpose of doing this is because we want to write this entire thing as a something whole squared, right? Okay, that's our purpose, this entire fraction. So let's see, we have that much info with us. So we want to apply an identity, and there isn't a sum of squares identity. So we'll have to use the two numbers whole square identity here. So we'll have to, of course, introduce a new term, right? So let's see, this is continued here, right? So x naught x squared let's use let's see, x squared. So we'll have x squared plus 1 squared. Now what we want here is so let's see the identity first. X plus y whole squared is equal to x squared plus y squared plus 2xy, right? We know that's the identity. Okay, so yeah, so here we have this equation. So we want to convert this thing into this form, so we can a better, neater form. So let's see. Yeah, so we can, okay, so we'll add up plus 2x squared. Perhaps that makes sense. Maybe that makes sense. Let's see. Hopefully so far it makes sense, right? So now see, we did that much, right? So but of course we can't make it unequal, so we'll have to subtract 2x squared. There we have that, right? And this is like, associativity property of real numbers. We are not going into complex number. I'm too scared to do that stuff. Okay, so we've got that much done, right? Now let's see. Now this is still equal to that, right? Because we subtracted this stuff. So let's simplify that using this identity that I just showed. So this would be x squared plus 1 whole squared. Okay, yeah, that sounds about right. Minus 2x squared over x squared. Makes sense, right? Right, but that still isn't as neat as I wanted to, because that's 2x squared still exists. So let's remove it. That's how fractions work. So we can do x squared plus 1 whole squared over x squared minus 2x squared over x squared. So in this case, we can just remove the x squared and x squared, and hopefully you know why. If you don't, then I don't know why you're watching this. Right, so this just becomes 2. And now, see, we can simplify this into x squared plus 1 over x whole squared minus 2. Right, so that's still not factorized, right? That's still pretty dumb so far, right? Yeah. And then, like, as I told you, this is a really forced factorization. This is not, good in any sense. Now I'm going to rewrite this 2 as, now we'll write this the same way, right? X plus squared plus 1 over x whole squared, but I'll rewrite this 2 as minus root 2 squared. And that's still the same because the square roots cancel out. The square root and the square cancel out, right? So that's root 2 squared. And now we can use the difference of squares formula, right? And the difference of square formula, if you don't remember it, a square minus b square is equal to a plus b, a minus b. That should make sense. Exactly, right? A square then minus b square, then ab, then ab plus ab, then minus ab. So it cancels out, and it's pretty good. So now we're going to use that, and then we get now okay, I'm going to write this stuff out here, x squared plus 1 over x squared, our original part. And now we're going to take this and use this identity on that, right? We're going to take this expression, this identity. So you have x squared plus 1, so 1 over x minus root 2, right? That makes sense. And then we'll do x squared plus 1 over x, and the same thing again, x plus root 2. And hopefully that makes sense to you, right? Okay, makes sense. Let's see. Now, well, we can simplify this a bit more, I think. Okay, we can make it more neat, right? Not least simplifying it, are we? That's our original expression, right? Right here. That would be equal to, okay, so let's see how we can simplify this one. X squared over x, that would be just x plus 1 over x, that would be plus x to the minus 1, that's the inverse. And then minus root 2x will become, so let's bring that into. Okay, I'm going to do it in one more step, because this seems too confusing right now. Now, of course, you could just stop there, but that still doesn't look neat. In fact, that looks much neater than that mess. Right, so this is, okay, I'm getting low on the board now. And I'll just write it here. Yeah, that's fine, right? That's fine. So we have that expression, so let's see. Well, we'll bring the root 2x right? So x squared plus 1 minus root 2x over x. Yeah, that makes sense. And then this minus changes to plus, squared plus 1 plus 2x over x. Now see, this is not arranged in proper orders. We'll do that in the last step, right? And that would make sense. Now we'll distribute the denominators so that it looks better. Okay, that looked terrible, sorry. X squared plus 1 over x squared. So x squared plus 1 over x squared, our original expression, is equal to, let's see, so x squared over x, that's simply x, plus 1 over x is, okay, well, let's write. So that would be, now we'll write it in orders, right? So that would be minus root 2 plus 1 over x plus x inverse. That looks neater, so I'm gonna write it like that, right? And here I think just plus, minus sign changes to plus, so yeah, that's pretty neat. X inverse. that looks pretty good. Now, okay, trying to factorize it anymore is just going to be too forced, and I don't want to do that, right? Now, this was the entire note, which is pretty big. So, okay, that looks pretty good, right? Let's just mark that answer there. That's pretty important. Okay, that's pretty cool. Yeah, that's pretty visible, hopefully. Okay, now I'll just set back a bit because, hopefully that's understandable, the note. Now we'll plug that into that part so that we have an absolutely factorized Harambe with us. Yeah, I'm gonna rub out the identities. They look really neat. Yeah, rubbing out the identities as you do. So let's mark out the border of that one. Yeah, let's use the blue pen for this one too. Whatever. So we have AR of Harambe on a capital H for legal purposes. So we have AR of Harambe was that, right? So we can write that as this monstrous expression. Now I'm gonna have to see. Yeah, actually this sounds right. And of course I'm gonna use the combinative property of real numbers, assuming x is real, which I am assuming. Real. It applies for, yeah, okay, real numbers. Assuming x is real, I'm gonna, move this part here because I like plus before minus. Okay. So we have x naught, lo and behold, x naught plus root 2 plus x naught inverse times x naught minus root 2 plus x naught to the minus 1 power. Wow, okay, that's good. I don't know, do I want to verify that? That's gonna be too long, isn't it? I guess we can check. I have a lot of time on my hands. Okay, so let's multiply out each thing, right? X naught squared, so we have an x naught squared. Then we have a x inverse squared, that would be x to the minus 2, not to the minus 2 power. Then we have a root 2 squared, which will be plus 2. Then we have a 2x naught, then minus root 2x naught, so root 2x naught minus root 2x naught, right? And these terms just cancel, I'm gonna rub them out. Okay. No, actually I'm gonna write them out, right? Yeah. Root 2x naught. Okay, any terms from the middle one, I think they cancel out. We'll check, I guess, yeah. Root 2x naught. Okay, you know what, this is confusing. Shit. I wanna go term by term. Yeah, this looks pretty bad. Okay, let's call this, yeah, I'm gonna call this minus root 2x naught. And then x naught times x inverse, right? What's that gonna be? I don't know. What's that gonna be? So when you multiply two powers, that's okay. So it's just going to be plus 1. Huh. Well, how neat. Okay, that is pretty good. So root 2, so that's, oh no, sorry. Plus root 2x naught, yeah, those two cancel out, as I said. Minus 2. Hopefully the constants will cancel out by the end of this. Plus root 2x now, okay. Plus root 2 x naught inverse, that makes sense. Okay, that makes sense, right? Now we have an x naught inverse, so x naught, so that's just going to be plus 1 again, plus 1, and there we have it. And then minus 2x naught inverse, as I told you, that would cancel out too with this term. That's pretty good. And then we have plus x naught to the minus 2 power, right? That's the entire thing written out. 1 2 3 4 1 2 3 1 2 3 1 2 3. Okay, that makes sense. 9 terms. Now let's simplify it. So these cancel out, these cancel out. Now this plus 1 and plus 1 becomes 2, and this is minus 2, so they cancel out. And at the end, let's see what we have left. So we have x naught squared plus x naught, the minus 2, x naught squared plus 1 over x naught squared. That's a proof. PF. That's a proof. Okay, that's pretty good. Wow. Yeah, this turned out better than I expected. Damn. Okay. Harambe is neat.